16 reads, compute the standard deviation of the average scores of Mr. Q's 5 classes. I have 5 classes, some statistics, some algebra 2, but that's the average grade, overall grade for each class. So, 100, 85, 100, 90, and 100. Show your neighbor your process, please, to make sure they got that down by now. All right. Send me your warm-up, please, on the screen. I already sent you the screen. And get us started, please. Help me out, Jay. What do I do first? Ascending order. So we got 85, 90, 100, 100, 100. Next step, Darian. Find the mean. And we know it as what? X bar or what? Mu. So we have 100, 100, 100, 300 plus 175. That's, is it 475? 475 divided by 5. That gives us what? 95. Hands, have you got that so far? All right. So from there, what do we do next? Pass the one, Darian. Subtract the mean from each of the data. So we got minus 95, minus 95, minus 95, minus 95, minus 95. And that's going to give us, let's see, this is negative 10, negative 5, 5, 5, and 5. Hands, have you got that? All right. Next step. Pass them one. Julius. Square each of these. So squared, that gives us 100, 25, 25, 25, 25. All right. Pass someone, Julius. Next step. What do we do next? So find the mean again. So X bar. And this gives us, let's see, 25, 25, that's 100, 200. Divided by 5, that's 40. All right. And our last step, pass them one. What do we do at the end? Square it. Square root. And that's how we find our sigma or our standard deviation. What'd you get for your square root, Julian? 6.32. Hands, have you got that? That is correct. All right, send that in, please. Bless you. And I'm pretty sure we're pretty solid with the process by now, right? From 1 to 5, how comfortable are you with the process of standard deviation? Yeah, 5, 5, 5 for us. So check this out. Today we're going to be adding a little bit more. Like I said, I didn't want to give you everything at once because this is something that, like I told you before, gives people problems. It's like their problems. Anyways, so I'm going to add another layer today. So like that, we're taking baby steps to where I want us to be. All right. Copy the agenda. Warm up number 16. Done. Today we're continuing with standard deviation, and I'm introducing something called the normal curve. The normal curve. Tonight's home play is only 2 problems. Only. Thank you, Mr. Hugh. You're welcome. And but like I said, hopefully you'll see how that transfers pretty well to what we've been doing so far. And just a reminder, some of you need to like really expand the picture. Some of you are like taking the picture from far away. Please, pretty please, with a cherry on top. All right. So, we good? Access to your home plate. Copy this code, please. FR9QI. 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 What's that? Oh, okay. All right. So last night's home plate, 9 problems. Go to Canvas right now. Turn that in, please. And tonight's home play are these 2. And once again, this is being recorded, so you'll see it in the YouTube video, or you have the code to go to Nearpod on your own later on. All right, get a Cornell note after you turn that in, please. I'll give you some time to set up. Go. So our objective for today, I can compute the standard deviation, which we already know, and of the data, and represent on a normal curve. That's the next part that we're going to introduce today. So we're still on standard deviation, and we are going to continue computing that, and now we're going to be representing that on a graph known as the normal curve. Let me send that objective to you. It's on your screen. For the sake of time, I'm going to move up forward on my screen. Here we go. So, recap. Did we do example 2 together? Yes? I gave you guys a table when we started with standard deviation, and it was the process as to how to find our standard deviation given a set of data. We also included mean, median, mode, and range, and so on and so forth. We had some home play on that. We did some more examples when we came back, and so on and so forth. All right. So, let me pause the music. Now, that's fine and dandy, but what is standard deviation? Write that down. Standard deviation. Write standard in blue, deviation in red if you have colors. Standard deviation has an actual meaning. It's actually a definition within itself, but we just need to know what standard means and deviation means. So standard. A standard is what we call something established that is common or that is a custom. A standard is something that's established as common or as a custom. A standard is something established as common or as a custom. A standard, something established as common or as a custom. For example, one custom that most people have is having breakfast, lunch, and dinner. That's something that's established. All right? Let's go to deviation. What does deviation mean? Deviation means departure from something that was established as custom or common. Departure from established, custom, or something that's common. So, if having, Darian, do me a favor, can you fix that frame, please? My OCD is kicking in, please. Push it back. Hey, push it back from the top. There you go. Woo. Saved. Guys, you have no idea. Sometimes, like, if something's not spaced correctly and stuff like that. Anyways. All right, here we go. So, if the most common thing for everyone is to have breakfast, lunch, and dinner, what does it mean to have something that's deviating from that? Deviation. That means that there's someone that doesn't have breakfast, lunch, and dinner. Maybe they just have what? Breakfast and dinner. That's a deviation from something established. How about someone that only has lunch, one meal a day? That's also deviation, but we're going to see layers of deviation right now when I show you with a graph. How about someone that doesn't eat sometimes in one day? That's a major deviation of something that was established. Does that make sense? Something that's custom, and then deviation is that. So standard deviation is something that goes away from something that's established. So how does that translate into statistics? Look up, please. So standard deviation, you find it by computing, which is the process that we learned, but now we're going to be graphing it. So underneath that, I want you to draw this, please. Students, this is known as a normal curve, students. Also known as a bell curve. Tell your neighbor why it's called a bell curve. Tell your neighbor why that's called a bell curve. Hello? Yes. All right? So try to draw it as best you can. I know some of you are artistically challenged, but it's okay. Try your best. It's not going to be perfect as mine. Are y'all ready? So notice it's a perfect bell curve, but the top of the bell curve right here creates something that hopefully you guys remember from your geometry class, symmetry. Symmetry, right? So if I was to split this in half, do that with me, split it in half. There it is. So now we have symmetry. The same area to the left is to the right. Now, that line that we just drew, label it X bar. Tell your neighbor what that means. What does that mean? What does the X bar mean? Yes, mean or average. All right, so once we find the mean, that tells us that that's going to be our standard, something that's the most common. However, look up. Draw one line to the right in black. Space it out about right there. And one line to the left as well. We're going to label this, look up. Our Greek letter, yes. That stands for what? Tell your neighbor. What does it stand for? Standard deviation. So put a little plus sign. Anything to the right of our mean is going to be a positive deviation. Anything to the left is going to be our what? Negative standard deviation. That is correct. That's our first standard. So in the middle and here, shade these two sections. This is known as our norm. That means that's the average or the most common section to look at. All right, so far so good. Like I said, so the mean right here should be people that eat breakfast, lunch, and dinner. Yes? The first standard deviation going upward would be that someone eats an extra meal throughout the day, like a snack. However, what would be the negative standard deviation? So, what would be a negative standard deviation of that? All right, looks like Jacob got it. Jacob, what would be a negative standard deviation from eating 3 meals? Yeah, go ahead. Not eating 3 meals, so eating only what? 2 meals. So therefore, do you think there's someone that eats their 3 meals plus maybe 2 snacks a day? Yeah, so let's do one more line over here and one more line over here. And this is our positive 2 standard deviation. And to the left, it would be our what? Negative 2 standard deviation. So what does that look like? Well, if our standard deviation is having breakfast, lunch, and dinner, the first standard deviation, somebody has a snack in between. That means 2 standard deviations. There's somebody that has how many snacks? 2 snacks. However, what does it mean to be here at the second, negative second? Talk it over to your neighbor. What does it mean to be at the negative second standard deviation if the standard is 3 meals? All right, looks like Donna's got it. Very good, Donna. I see you. Mitos got it. Let's see. Ricardo, what do you think? Someone that doesn't eat 2 of the meals, so they're only left with what? 1 meal. Okay. So if that's true, that means there could be 1 more standard deviation. Is that correct? All right, so let's do 1 more to the right. And this is our positive 3 standard deviation, and 1 to the left, which is our negative. Positive 3 standard deviation, negative 3 standard deviation. All right? So, let's see if we understand what we're looking at. Our standard deviation, or our mean, is that people eat how many meals? 3, breakfast, lunch, and dinner. If I go 1 up, that means somebody eats 1 more meal, whatever that means. If I go one down, that means someone eats what? One meal less. And up, less, and so on and so forth. Now, do you see how as we progress to the end, it's more rare? Does that make sense? As we progress to the end, it's more rare. Okay? So, questions, comments, autographs? All right, let's add some percentages. Look up. In here, I want you to write 34.1 and 34.1. These are percentages. Because under the curve, there's a certain percent on that area. So on one standard deviation, if you go up, it's 34.1. If you go down, it's 34.1. So that means together, what would be the normal percent of people that eat at least 3 meals or one more or one less? So you remember the total percent. What is the total percent, everyone? 68.2. That is correct. 68.2 is the norm. Let's go to the next standard deviation. 13.6. 13.6. The next standard deviation. 2.1. 2.1. And last but not least, 0.2. 0.2. All right? So, today, now that we know what the bell curve is and what everything represents, today we're going to actually transfer what we learned in regards to the process of standard deviation and graphing it onto a bell curve. Okay? All right? Do me a favor. Send me your notes, please. I want to see what you wrote down. Your beautiful sketches. As soon as you're done with that, copy example Q. Don't copy the verbiage, just copy the data, please. And it reads, compute the standard deviation, sketch a bell curve, any conclusions from your data. Mr. Q asked 5 students how many hours of sleep they got last night. And we did this before, but I'm bringing it back again. So copy the data, 4, 8, 7, 10, and 6 hours. 4, 8, 7, 10, and 6 hours. I'll give you a head start. Find me the standard deviation, please. Go. All right. Really quick, before you finish, show your neighbor where you're at. See, make sure that they got the same process as you. All right, Ricardo, pass them one. Donna, get us started. What do I do? Order 4, 6, 7, 8, 10. Pass someone. Vanessa, next. Add it. 35. And then? And that gives us, so our mean is 7. Hands, have you got that? Pass someone. Green, go. So take all the data, subtract by the mean, subtract 7, subtract 7, subtract 7, subtract 7, subtract 7, and we get -3, -1, 0, 1, 3. Hands, have you got that? Pass them one. Square each one, so this is 9, 1, 0, 1, and 9. Pass them one. So add all them up, and that gives us, what is it? 20, and then Divide by 5, and that gives us our new mean, which is 4. Hands if you got that. Therefore, see what I did there? Our standard deviation, everyone, and actually this one's going to be exact, so is equal to 2. All right. So, before we graph this, let me pause the music in the back. Writing pencils down, look up to the screen. All right. So, according to the problem, I asked 5 students how many hours they got of sleep. So, first data that we got, which is 7. What does that mean? Tell your neighbor, what does that mean? What does that number mean? All right, looks like Jessica's got it. What does that mean, Trinity? It's the average number of hours of sleep. So the 5 students, their average hours of sleep is how many? 7. However, what is the standard deviation? 2. That means you either add what? 2 hours, or you what? Take away 2 hours of sleep. Does that make sense? All right, so now let's represent that in a normal curve. So let's draw the curve over here on the side. Nice and neat like mine. Kind of, sort of. Are you laughing at me, Anthony? Oh my goodness. All right, let me fix it. Oh, my bad. How about them apples right there? Yeah? All right, here we go. All right, so where do we start? Well, we graph our line of symmetry. We label it what, everyone? X bar, and we give it a value which is what? 7 hours. That is correct, 7 hours. Next, let's go to our first standard deviation. First standard deviation, up and down. This is positive standard deviation and negative standard deviation. So, tell your neighbor where we're at now. Where are we at now? If we started with 7, what is the first standard deviation up? Where are we at now? Everyone? 9 hours. Label that. How about 1 deviation down? Where are we at now? At 5 hours. That is correct. Let's label the next standard deviation. Next standard deviation. That's our +2 and -2. Label it to see where we're at now in hours. Label it. Where are we in hours? Tell your neighbor, please, to make sure they got it. Where are they in hours of sleep? All right, Diego, where are we at? What is it? 11 hours. And on the negative? 3 hours. All right, so far so good. Label the third one, please. Third standard deviation. +3 deviation, -3 deviation. And tell your neighbor where we're at in hours. In hours. All right. Go ahead, Martin. How many hours for the third? Okay, we went from 7 to 9 to 11, and the next one is 13 hours. How about on the negative? We went from 7 to 5 to 3 to... What is it? 7, 5, 3, 1 hour. Hands, have you got that? All right. Not bad, yes? From 1 to 5, how comfortable are you with this? 5 fours, 5 fours. We got it, right? However, this is the norm. Shade the norm. There's the norm. Now let's look at our data according to the norm. According to the norm is from what hours to what hours of sleep. Tell your neighbor. Then Miros is going to enlighten us. What is the norm? From how many hours to how many hours of sleep? What is the norm? Miros, what is our norm? 5 to 9. So label that 5 hours to 9 hours of sleep. Okay? Looks like Julian's got it. Julian! So if from 5 to 9 hours of sleep, look up. And this is the numbers that we got. Look at it. 4 hours, one person. 6 hours the next. 7 hours the next. 8 hours the next. 10 hours the last. Look at those numbers and look at the norm. Think about it. What would be a conclusion that you would come up with according to this graph and according to this number? Talk it over your neighbor. What would be a conclusion that you would come up with? Conclusion! Looks like, let's see, Julian's got it. What is our conclusion, Julian? 3 students get the normal amount of sleep. 10Q. Hands, if you agree with that statement? That is correct, because the 4 doesn't fall in the norm and the 10 doesn't fall in the norm. Send me your notes, please. And that's going to be the home plate, guys. So I'm going to give you 2 data problems where you just need to find me the standard deviation and transfer it to a bell curve. However, before we leave, from 1 to 5, how comfortable are you with the entire process now up to right there? 5 fours, 5 5s, okay? Send that in, please. We'll stop right there. Make sure you put away my calculators. You got about 45 seconds to the bell. And those of you following on YouTube, make sure you do your practice on the 2 problems that were on the screen. See you guys later. Peace.